Can you weld cast iron with an electrode? A neighbor brought me this pump to repair it for him. It's from his truck. This pump is made of cast iron. It's cracked and leaking water, so I have to weld it. Ideally, the neighbor would buy a new pump, but he can't afford it. So I'm going to repair it for him so he can use it until he can buy a new one. Taking advantage of this, I thought of making this video to show you a method I learned a long time ago. To weld cast iron with an electrode, you simply need an electrode and a cable. The ideal thing, to do this welding, we should use a nickel electrode, which is ideal for welding cast iron. But these electrodes that contain nickel are hard to find and very expensive. That's why I'm going to show you this technique we're going to use. We're going to use a 6013 electrode and a cable. As I said before, what we need is a cable that has copper inside. In this case, I have this cable that's 1/2 meter long and 10 millimeters thick. Now what I'm going to do is take it apart. I'm going to remove the cover to get the copper out. For that, I made this homemade tool, which is a piece of wood with a hole and a pointed screw. This will make the cable's cover split when I pass it through. The first thing I do is give it a gentle pass, and on the second pass, I tighten the screw a bit more so it cuts all the way through. The same thing. Once it's cut, you have to remove the copper. To show you what the process of this welding would be like, I'm cutting this pan that's made of cast iron. How can you tell if it's cast iron or not? When you're going to cut or polish, cast iron doesn't produce many sparks, and as you can see, when cutting this pan, very few sparks come out. And that's how you know it's cast iron. But why can't you weld cast iron with just any electrode? Cast iron is an alloy of iron. Cast iron alloy has a high carbon content between 2 and 4%. A high carbon content makes it hard but brittle. During welding, the high temperatures and rapid cooling can cause carbide formations. It's a hard and brittle area in the joint, and it can also cause cracks. If the copper you take from the cable is very thin, you need to twist 2 strands together. If the one you take is 1 millimeter twisting, just one is enough to make it faster to twist. I'm helping myself with the drill. I put in the 6013 electrode of 2.5 millimeters, and I'm going to twist it this way. Once it's twisted, you have to bring the wire to the tip, but it should be about 1 centimeter from the tip of the electrode. The space between each turn should be between 4 and 5 millimeters. Just like I'm showing you, before soldering the piece, you need to bevel it so the solder can penetrate better. Normally, when welding cast iron, you have to heat the piece in order to weld it. This is to even out the heat generated by the electrode, and this prevents it from cracking. But in this case, since we are not going to use a nickel electrode because it is very expensive and very hard to find, with this technique there is no need to heat the piece. First, I am going to show you how to weld the pan, and then I will weld the pump. Since the electrode has copper wire wrapped around it, you need to use high amperage. In this case, I'm going to try with 90 amps. The first thing you need to do is strike the arc with the electrode. It has a material that isn't useful to you, and then you tack the piece. After tacking, remove the slag to continue welding, and that's it. That's how the weld turned out. As you can see, you can notice a bit of a copper color. Although I noticed it lacked a bit of penetration, the bead turned out pretty good. And now, to see if it's really sealed, I'm going to put a little water on it to see if it leaks. When I added water, it didn't leak a single drop, so it's well sealed. This pan would need to be welded on the top side to finish it. But since it's a test piece, just so you can see how the process works, I'm not going to weld the top part. And now it's time to weld the water pump. Since it was cracked, you have to cut along the entire crack with a grinder and reach the bottom of the crack. Then you need to make a bevel, so the weld can go in properly. Like when I welded the pan, I didn't have enough amperage. So now I'm going to raise it to 105 amps. That's how the piece got welded. But why is it that when you wrap a copper wire, you can weld cast iron using the wrapped copper? When welding, copper conducts heat efficiently, distributing it evenly across the piece, which reduces the concentration of heat in a single spot. It also adds material to the weld. When you're welding, small copper particles melt, forming a more useful metal bead and reducing the formation of carbides in the heat-affected zone. And the copper softens the electric arc, allowing for greater control in the process. If you enjoyed this video, please follow me, it really helps.